All right, Frankie, this question is for you, okay? M66b, and given two lines mx minus y equal to 3 and x plus my equal to 3m, solve the following equations. First one is, for all real numbers m, find the locus of the points of intersection p, x, y of the two lines. This might be pretty confusing. First of all, we have to kind of understand what does locus mean, right? What's the meaning of locus? So I run through ChatGPT. I think this is a better explanation than me explaining it. So what does the locus of a point of intersection mean? The set of all points that satisfy a certain condition. In this way is that our conditions are mx minus y equal to 3 and x plus my equal to 3m. And the really changing factor is the value of m, which kind of corresponding to the second point. Imagine two curves and lines that change position according to some rules, parameters. In this case, the rules and parameters are the m, change of m. As they move, their intersection points moves too. The path traced out by that moving intersection point is locus. If you're still having some issues with that, I ran through it using decimals. So let's say, for example, I have already changed both of the equations into the standard linear equation form, right? For example, the first one is basically mx minus 3, right, equal to mx minus 3, with m as the coefficient and the variables that we can change. I call it slider. And also with another equation, y equal to 3m minus x over m. That's basically this guy here, right? X plus my equal to 3m. So let's take a look at what happened, okay? As I'm moving this along, right, from 10, let's say, all the way to negative 10, and see what happens, okay? As you can see that the intersection changes places, right? Changes places, right? It's always moving. If I change this a little bit smaller, it's quite small already, 0.05 already. If as soon as I'm changing this smaller, you can see that the intersection of the two lines keep changing. So basically the locus summarizes and asks you to conclude that the circle, right, that's basically the trace of all the intersection based on the change of m. Okay, so one more time. The locus, you just need to describe the circle, right, that follows the trace of these two lines intersecting with each other, right? For example, from 10, negative 10, all the way to 10, right? It's basically rotating, it's going down, and then it's going up. This is basically a circle, right, all the way. But did you notice something? If I moved all the way to negative 10, there's just some point that these 2 points are not going to intersecting. For example, how come it just cannot pass this, as they move, as you can see, it cannot pass this point over here. And also it cannot pass this point over here. So what was the issue? I thought it was because that, our numbers are set to be, the domain set to be too little. So I changed it to 100 and negative 100 and 100. So let's try this one more time. If I change from negative 100a, I see that it's almost intersecting it. But still, if I enlarge it, if I'm moving to 100, it just never touches it. So to prove my point, I did this change as well. And let's see if that's the same case, right? Again, very, very indefinitely close to it. But if I enlarge it, you will still see it just does not touch that point, which means that, okay, there is, I would say, an issue with this. Is there a point, it seems like it's 0, 3, that's the coordinate, that this intersection will never touch. So if it's not touching, which means that the locus should not include that as well. So basically 0, 3, that point, it shouldn't be called a part of the locus. So to verify that one more time, right, let's make it a little bit smaller and change the numbers back, negative 10, and also this one is 10, okay? All right, so let's move this one more time. So you see that this is a circle coming. All right, so with that knowledge being said, let's do some calculation to see that really if this point is the non-touchable or untouchable point for us. So for us to evaluate this question, we have to set x and analyze x. Either x is going to be 0 or x is not going to be 0. So that's exactly what this question is, the steps are going through, right? So first, For number one, mx is equal to y plus 3, right? We said that we're going to analyze when x is not equal to 0 first. All we need to do really is just, hey, we change the shape of it just like how I did it over here. Instead, it's representing m by y and x. So once that's done, we can substitute this m equal to y plus 3 over x into equation number 2. Once we put it into equation number 2, notice that, hey, in this case, since my x is not going to be, right, not going to be 0, this is solid, this is good. So by multiplying both sides by x, I get x squared plus y squared plus 3y equal to 3y plus 9. And then if you do the arrangement, you will get x squared plus y squared equal to 9. And this is going to be our equation number 3. So given number 3, we already know what number 3 is. What if, okay, what if my x is going to be equal to 0? In this case, it's contradicting to our fraction equation over here, right? Basically, it means that if x is equal to 0, because this equation number 3, x squared plus y squared is equal to 9, I'm able to tell that if x is equal to 0, then y is definitely going to be positive negative 3. But since x cannot be 0 in this case, it might be a little bit complicated here, but if you sort out the understanding here, we're using this one to say that, okay, I'm analyzing when x is not going to be 0. However, when I change the shape of the equation into x squared plus y squared to 9, I'm going to assume that what points are the exclusive points, which it needs to be excluded in my operation. And hence, when x is not equal to 0, 0.03, which is 0 and 3, and 0.0 negative 3 are excluded in number 3. So I already know, okay, if I were to describe the locus of this, it's going to have the whole circle that's formed by the trace of this intersection of these two lines will be 0, 0 as the origin, all right? 0, 0 as the origin, and it can go anywhere except of 3 and negative 3. Okay, that makes sense, right? However, it does not stop here because we're also going to analyze that when x is equal to 0, what happened? So when x is equal to 0, right, from number 1, everything that we did over here, if x is equal to 0, so this part is going to be 0, so y is going to be negative 3. That's pretty straightforward, right? Y is going to be negative 3. If I substitute 0 and y equal to negative 3 into number 2, which is this equation over here, if I substitute it into it, x is going to be 0, the over here is going to be negative 3m is equal to 3m, which means that there's no way that m except of 0, m can be anything else. So when m is actually equal to 0, so as you can see even from the left side slider over here, let's see what happens when m equal to 0, okay? When m equal to 0, which is also the time where x is equal to 0 too, that's our second evaluation, second analysis over here. Let's set it to be 0. Perfect. As you can see that it's disappearing, right? The green line disappear. Why? It's just because that the black line actually covers the green line, but it still intersect over there. So as for locus, right? Again, going back to our explanation of locus, the two curved lines that change position according to some rules, as they move, their intersection point moves too. So perfect, that intersection points moved as well, all the way, right? Even touches the 0, negative 3, but however, it just couldn't touch the 0, 3, right? So as a conclusion of that, and according to the graph that I draw on the left side over here, my conclusion is that for these two equations, mx minus y equal to 3 and x plus my equal to 3m, right? After that, I did the little alteration for these two equations. Based on the graph and also based on my calculation in terms of the points, it can touch anywhere, but just not 0 and 3, right? Just not this 0.3 points. No matter if it's going from a clockwise or anti-clockwise, it just couldn't touch that point. And it kind of proves my point, our point over here by number 1. And by number 2, y is equal to negative 3 is no problem as long as m is equal to 0. But by number 1, this is not okay. So as a conclusion for this, 0, 3, it's going to be excluded no matter x is equal to 0 or not equal to 0. However, 0, negative 3 can only be excluded when x is not equal to 0. However, when x is equal to 0, it can still happen. It can still be working. So as a summary for this, from 1, 2, which is my first analysis when x is not equal to 0, and my second analysis when x is equal to 0, the locus is a circle with its center at point 0, 0, which this is the origin for this, this circle, and radius 3. It's pretty straightforward, right? That if this is the circle, then over here is going to be same, over here is going to be same, over here everywhere is going to be same, except and excluding the point 0 and 3. And that's actually how you explain and get the locus out of this question, okay? All right, second question is actually easier because you're just talking about you're setting a domain for m. So before, remember, we're talking about this m being from negative 10 to 10, even we tried from 100 to negative 100, right? So what we can do right now is that we can set this to 1, a 0, we can set this to 1, and let's move it around and see what we get. Ah, look at this, right? It's just coming from here all the way to here. All right, seems like if I were to draw on the screen, seems like it's a little curve over here. It's only part of this whole cycle, all right? Whole circle here, it's just part of it. And then which means that if it's just a part, and I already know that the whole graph is a circle, right? Origin at 0, 0, with 0, 3, they cannot be touched, excluded in a way. So my graph or my locus with the domain of m in between 0 and 1 should be just here. So if you draw the graph, it's going to be from here to here. It's the curve over here, okay? So that kind of summarizes this question. If you still have any question, let me know. And I believe with this, you can try 67 as well, okay?